In the latest AI breakthrough, Microsoft's Cosmos-1 has made a huge leap towards achieving artificial general intelligence, known as AGI, which is the holy grail of AI researchers. While ChatGPT is limited to being an expert with text and Midjourney is limited to being an expert with images, Cosmos-1 finally takes things to the next level by being an expert with both. By learning from multiple data sources, such as images and text, this multimodal AI model could provide a better understanding of the world, with the idea of combining knowledge from different modalities to help solve complex tasks, like describing images in natural language and more. Furthermore, experts agree that multimodal perception is a crucial component of intelligence and therefore essential for achieving AGI, with Cosmos-1 shaping up to be a powerful multimodal large language model with the capability to propel the AI industry to new heights. In addition to language and multimodal perception, a possible AGI would also need the ability to both model and act on the world, with the Cosmos-1 multimodal large language model having the unique ability of modeling the world through language and images. To achieve this feat, the model was trained using partially related image and language data, including word-image pairs. Additionally, large amounts of internet text were used to train the model, as is common practice with large language models like ChatGPT. The result is that Cosmos-1 has the remarkable ability to describe images in natural language, recognize text on images, write captions for them, and even answer questions about them. What's more, the model can even perform these tasks on direct request or in a dialogue situation similar to ChatGPT. Cosmos-1's language capabilities are on par with those of large language models, allowing it to leverage methods like chain of thought prompting to achieve even better results. When it comes to Cosmos-1's ability to understand and perceive visual information, in a recent visual IQ test, the model outperformed chance by between 5 and 9%, demonstrating an ability to perceive abstract conceptual patterns in a nonverbal context. This was achieved by combining nonverbal reasoning with linguistic pattern recognition, a feat that was previously thought impossible by AI researchers. However, the research team now acknowledges that there is still a significant performance gap between Cosmos-1 and the average adult level. Multimodal AI models like Cosmos-1 are proving to be highly effective at representing implicit connections between different concepts, as demonstrated by OpenAI's Clip Neurons study. With further development and fine-tuning, the potential applications of multimodal AI models in the real world appear to be vast, with their direction heading towards artificial general intelligence. But despite its success, Cosmos-1's 1.6 billion parameters are relatively small compared to today's large language models. So in order to unlock the full potential of multimodal artificial intelligence, they hope to scale up the model to include additional modalities in its training, with the intention of adding the ability to process speech next. In addition to expanding its capabilities, they also believe this can help them overcome many of the current limitations of the model. With the continued development of multimodal artificial intelligence like Cosmos-1, the possibilities for advanced AI systems appear to be endless, with Microsoft asserting that multimodal large language models like this will offer new capabilities and opportunities not available with current large language models alone. Amazingly, as the progress of artificial intelligence accelerates, AI is also bridging the gap between man and machine, as it can now literally read human minds with incredible accuracy. In this latest AI breakthrough, the Graduate School of Frontier Biosciences at Osaka University in Japan is utilizing a stable diffusion model to reconstruct visual experiences from fMRI data, which eliminates the requirement of training complex AI models. Instead, the team only needs to train simple linear models that map the fMRI signals from the lower and upper visual brain regions to individual stable diffusion components. The researchers map brain regions as inputs to image and text encoders, where the lower brain regions correspond to the image encoder and the upper brain regions correspond to the text encoder. This method allows the system to utilize image composition and semantic content for reconstruction. Reconstructing visual experiences from human brain activity presents a distinct opportunity for researchers to gain insight into how the brain encodes the world and to elucidate the relationship between computer vision models and the human visual system. The findings demonstrate that the proposed approach can produce high-resolution images in a straightforward manner without requiring additional training and fine-tuning of complex deep learning models. Additionally, the researchers offer a neuroscientific interpretation of the different LDM components, which provides a new framework for understanding diffusion models, plus presents a promising method for reconstructing images from human brain activity. Using fMRI images from the natural scenes dataset, the researchers conducted an experiment to determine if stable diffusion can reconstruct what subjects saw, and they found that the combination of image and text decoding yields the most accurate reconstruction. However, there were discrepancies in accuracy corresponding to subjects and fMRI image quality. Additionally, the researchers used AI models derived from the fMRI data to study individual components of stable diffusion, including the generation of semantic content in the inverse diffusion process and the processes that occurred in the UNet. Furthermore, in another AI-powered breakthrough deciphering the human mind, using a recurrent neural network known as an RNN, Stanford researchers have developed a brain-computer interface that can synthesize speech from signals detected in the human brain faster than ever. This latest BCI approach allows for communication at 62 words per minute, which is 3.4 times faster than previous methods. With artificial intelligence being increasingly applied in healthcare and medicine, this new speech-to-text interface can help individuals with speech complications to communicate effectively. Their system was successfully demonstrated in a patient suffering from an inability to speak due to amyotrophic lateral sclerosis, known as ALS, and was trained on a gated recurrent unit model. The intracortical microelectrode arrays were implanted in the patient's brain to capture signals at a single neuron resolution, which were decoded by the GRU model to produce speech. The researchers observed that when the recurrent neural network model was trained on a vocabulary of 50 words, the BCI system displayed an error rate of 9.1%. Increasing the vocabulary to 125,000 words resulted in an error rate of 23.8%, which improved to 17.4% with the addition of a language model to the decoder. The team collected a total of 10,850 sentences for training, which were elicited by showing a few hundred sentences each day to the patient to recite while the microelectrodes captured the neural signals. This breakthrough in BCI research has the potential to significantly benefit patients with paralysis or stroke, given its superior performance over existing methods. Previously, BlackRock Neurotech had the fastest real-world mind-reading device, performing at 90 characters, or roughly 19 words per minute, with an accuracy of 94%. While Facebook said that it intended to create a consumer-ready device capable of performing at a speed of 100 words per minute. But after providing funding for several years to the University of California without achieving its intended results, the project was later canceled midway through 2021. All in all, these breakthroughs in both multimodal artificial intelligence and brain-computer interface could lead to a world where the human mind is directly connected to a digital hive mind intelligence and global consciousness.